Welcome back, guys.
Hi, welcome back.
We're still here. It's still Parent-Teacher Conference night, so we're going to keep going quickly here. Polyatomic ions.
Polyatomic ions. Oh,
so
my.
Hey, look, this is already done for us, so we can just talk about it. So sodium, and then we go, oh, this is a polyatomic. I memorized these. That is bicarbonate.
With a -1 charge. So these are actually ions.
Right.
Bonding together. Oh, polyatomic
ions. There we go. So sodium bicarbonate, we call sodium bicarbonate.
Okay.
Magnesium and nitrate, we call magnesium nitrate.
Hey, how come there are two of them, Mr. Kane?
Oh, how come there's two? Well, nitrate has a 1- charge. There's only one magnesium, but magnesium always has a 2 positive charge.
So in order to make it neutral, meaning adding up to be 0.
Yeah.
Okay.
And notice I have to actually draw these parentheses in.
Why are there parentheses, Mr. Kane?
So that I can keep track of what subscript the charge goes with. Does the 1- go with the 2 or does it go with the 3?
Oh yeah, if you didn't have the parentheses, it would look like you'd have 32 oxygens, wouldn't you?
Yeah, or 32 oxygens, which would mean then that
really
I've got the 32 charge here, and magnesium would really have to make up for that. Okay, so we go on here to the next one. This is ammonium. I recognize that.
Right, that's a polyatomic.
And that's sulfur by itself, so we just call it sulfide.
Okay.
So ammonium sulfide. And if we're going to look at the charges here, this is a...
Mine does it all the time.
This is a 2-, and this is a 1+.
1+ according to... Okay, and there's... All right, so the math works out.
Right.
Okay.
Now this is ammonium sulfites.
Ooh, those are two polyatomics bonded together.
Which the charge on this is a 2-, right? I could probably put a parenthesis around it just for the sake of showing the math. There's only one of them. That means that the 1+, okay.
Wait,
There's
so
two
do you
1+.
mean, Mr. Kane, are you saying that parentheses have to go around polyatomics if there's more than one?
Oh yeah, definitely.
Oh, okay.
That way it keeps it all together.
All right, that's why there are parentheses around the ammonium, but not in the very first bicarbonate. Okay.
Right,
Got
exactly. Because there's only one of these bicarbonates.
Okay.
But there's 2 of these ammoniums, so you needed the parenthesis.
Otherwise, it would look like nitrogen and 42 hydrogens, wouldn't it?
Otherwise, this last one would look like this.
Which is ridiculous.
Yeah, 42 hydrogens in something is completely ridiculous.
Yeah.
So we slapped the parenthesis in there just to kind of contain the ammonium so you can recognize it.
All right.
Okay. So this is ammonium, NH4, and sulfate. Sulfate is our 2- charge, and the ammonium is still our 1+ charge.
Okay.
Okay.
That looks good.
All right. Type 3 compounds. Yeah. So naming type 3 compounds.
Okay.
First, the first element is still named first.
All right, just like before. That sounds good.
And the second element is still named with an IDE ending, so...
But isn't the first element with these compounds going to be on the right-hand side? Isn't that what one of those first slides said? This is going to be a nonmetal and a nonmetal, right?
These are 2 nonmetals, yeah.
Okay, so a nonmetal bonded with another nonmetal. All right, so 2 nonmetals. So no metals, no transitions, nothing like that. It's all coming from the right-hand side.
Right, all from the right-hand side.
All right.
And we use prefixes now to indicate the number of each element. So how many of each element that we
No
actually
charges.
have. No
Just
charges.
Prefixes will indicate the subscripts, yeah?
No charges.
Okay.
There's no Roman numerals. It's just use prefixes.
All right.
And we'll get the prefixes on the next slide, I think.
Okay.
But we all know the prefix for 1 because we all know what we call it when 2 men fight.
Yep.
Right? Mono e mono.
Okay.
1-on-1. So mono is never used on the first element if it's needed. So if I had something that had 1 of the first element, I wouldn't use the word mono on
Okay,
it.
because it's kind of understood if it's there in the formula, it's there.
Right. I need it for the second element, but not for the first.
All right, okay. So this is coming with rules too, isn't it?
Yep.
All right.
So these prefixes have to be memorized.
Mono for 1, di for 2. Okay,
Tri for 3,
tetra, all right.
tetra, penta, hexa.
Hexasepta, octan. All right.
Now, Miss G, I know some books differ. Do you call it septa or hepta?
I think it's septa for mine.
I think I call it septa also. I've looked in chemistry books and sometimes 7 changes.
Yeah.
Okay, but we're going to use septa. All right, so here we go.
Ooh, okay, 2 nonmetals.
So we're going to do it the same way, 2 nonmetals, phosphorus and chlorine. You got to look at the periodic table to kind of know which type it is, don't you?
Okay, yep. You got to know where they're positioned on the periodic table to know if they're a metal from the left or a nonmetal from the right. Both these guys are from the right side, so this is a type 3.
So notice I'm leaving some room in between and some room at the beginning.
Okay.
So phosphorus, how many of them are there?
1.
So hang on. I don't have to call it mono, do I?
Nope, don't use
we don't
mono
want
for the
mono.
first element, only for the first element.
So not for the first element. And then chloride, though, there's
5
of.
of. So that's penta.
Penta. P-E-N-T-A. So it's phosphorus pentachloride.
So if you wrote that name down, I would be able to write the formula. I know phosphorus is a P, and I know chloride is Cl, and
Right.
the penta indicates there are 5 of them.
Cl with the penta, which means 5. Yeah,
All right.
PCl5. Hey, I got the same answer.
There you go.
All right.
I like that.
That's good. Phosphorus.
Oh, we're
chloride.
right.
Oop, put them together, and penta appears in the middle.
There you go.
All right. So try these examples.
All right, so we're trying these examples. All right, let's see. How come hydrogen is a nonmetal?
Because it is a nonmetal. It's on the left side, but it's a weirdo.
Oh, it's one of those elements with so many different exceptions to the rules, isn't it?
Yep.
Okay, so let's see. There's 2 hydrogens. That means the prefix di. And you use the proper name for the first element, so hydrogen, so dihydrogen. There's 1 sulfur.
So I'm going to use mono.
Okay, so mono, and I've got to use IDE ending, so dihydrogen monosulfuride.
Except for you got to take off that ending.
All right,
Sulfur.
dihydrogen monosulfide.
All right, dihydrogen monosulfide. Looks good.
Good.
All right. Here we've got N2O3, so we got 2 nitrogens. 2 is di.
Dinitrogen.
So dinitrogen.
Okay.
And then 3 oxygens. 3 is tri. I remember that because my son rides a tricycle.
Yeah,
It has 3
yeah.
wheels. So trioxide. So
All right.
trioxide. So nitrogen, dinitrogen,
trioxide. All right, there we
Okay.
go. Ooh, okay, let's see. 2 chlorines, dichlorine.
Dichlorine, di.
Stamp. Dichlorine, let's see, 1 oxygen, but since it's the second element, it needs the mono.
Right, yeah.
And monooxide just doesn't sound right to me, Mr.
No,
Kane.
mono, hang on, let me try writing that down. Mono
That looks-
oxide.
Yeah, that looks and sounds
It's kind of difficult to say,
poorly.
monoxide. It's too many syllables.
Okay, so concerning vowels, there are a couple of rules.
You can take away a vowel
Okay.
off of a prefix if it makes it sound too difficult to say.
All right, so
I think that's the rule.
what I remember was no OO, no AO, yes to IO. Can you write that down? No OO,
O-O.
no AO,
A-O. No. Okay.
but yes to IO, because you'll notice in the trioxide, the IO stayed put.
Okay.
So I think that would be beneficial.
Okay.
No to OO, no to AO, yes to IO for vowels.
And I just always say that if it's difficult to say,
Yeah,
take the vowel off of the
prefix.
And it's always
Okay.
the prefix that you take the
Yeah,
vowel
it's always
off.
the prefix. All right.
Either way, you want to memorize that,
Yep.
whichever one's more useful. But we get dichlorine monoxide
Yep.
instead of monooxide.
Okay.
Last one here.
Oh, 1 carbon. So just carbon, no mono for that very first
Yeah,
element,
I was
right?
almost going to do that, monocarbon.
Ooh, yeah, no monocarbon, just carbon. Because that's pretty obvious that there's 1.
Right.
Selenium, yeah? So selenide,
Selenide.
and there's 2 of them. So
Diselenide,
diselenide.
Yeah, that's
Carbon diselenide.
Carbon diselenide.
All right.
Yeah, okay. All right. And the other reason why I like to tell people that we don't use mono is because sometimes in storerooms people like to put things alphabetically. Just
Yeah.
imagine how many chemicals would be on the M shelf.
You'd need a bigger boat.
You'd need a bigger shelf, that's for sure. Okay. Know these. I guess that means I should make flashcards.
And yes, and these are just straight up memorize them. End of story.
Yeah. Now there's a trick here if you look for it. If you remember the acetate ion, you can actually find it here, and this is called acetic acid.
Oh.
The sulfate ion is called sulfuric acid.
Okay.
The chlorine ion gives you hydrochloric.
Okay.
The nitrate ion gives you nitric acid, and the phosphate ion gives you phosphoric acid. So there's if I've memorized the chart, if I've memorized my polyatomic ions, memorizing these acids isn't that difficult.
No.
It's an extra hydrogen or
Yeah.
more than one sometimes.
So every acid formula starts with an H, doesn't it?
Yep, H.
Okay.
Heck yeah. Okay. And you guys might need to work on this, but I'm going to show you the trick here. the phosphate ion, PO4, is a 3 minus ion. How many hydrogen ions does it need?
3.
It needs 3 because of that, because it's a 1 plus ion.
So to make it neutral.
Okay, to make it neutral. I'm not going to do any of the rest. That's the only one.